took the electron from carbon, so there will be electrophilicity at carbon, electrophilic center developed at that. So it will be like this. Now what will happen here? You can see this is your carbon and nucleophile attacked on that, and then you can see O negative because oxygen took the electron from carbon, and then comes your B. B I'm going to represent with solid wedge, and A I'm going to represent it like this. As you know that this is planar because it's hybridization of carbon is sp2 central metal atom, and here it is sp3, that means tetrahedral. So this will not be the planar, this will not be planar, it will be basically out of the plane, inside the plane, 3D structure. After this what will happen? Now what I'm going to do, this is your second step, step 2, and this is fast, this is fast. Now what will happen? We are going to react this with H plus acid. So as you know that positive will go to the negative, so what we will get finally, so this is your nucleophile, this becomes your OH, and this becomes your like B, and this becomes your, are you getting my point? Yes or no? So this is also called tetrahedral intermediate. You can write below this tetrahedral intermediate. Intermediate. And here this is addition product. This is called addition product because we get this product after adding something, that is nucleophile. So this is called addition product. Please do write it.
What should I?
Oh, let me know when you are done with this. Are you done with this?
Shut up, Mr.
Okay. So we are going to talk about this reactivity towards nucleophilic addition reaction. And it's very easy. If I'm going to ask you a very simple question, reactivity. For reactivity, let's say, as you know that this is your ketone and you have a nucleophile. And let's say this is your ketone aldehyde, and you have a nucleophile. What do you think? Which one will react faster? As you know that the nucleophilic center is this. So this will attack here, and this is also nucleophilic center. This will attack here. What do you think? Which one will react faster, aldehyde or ketone? Humam and Austin.
Aldehyde.
Humam, did you say aldehyde?
Yes, sir.
Okay, tell me the reason as well.
Aldehyde is more reactive than ketone.
Aldehyde has more.
Is more reactive.
How can you say that aldehyde is more reactive? Like, can you tell me why aldehyde is more reactive? Your answer is correct, but the reason that you told me is not correct. Austin,
Reason
yes. Austin, any comment on this? No, sir. So basically, your answer is correct. Wow. See, aldehyde will be more reactive than ketone. It is only because, see, R is there. R is a bulky group. Yes or no? Bulky matlab means that is CH3. With carbon, 3 hydrogen will be there, and there is only one hydrogen. And both side you have bulky group in ketone. So when nucleophile wants to attack, there will be a steric hindrance between the alkyl group and nucleophile. And here you can see in aldehyde from one of the side, other side you have alkyl group, bulky group, but there is another side which has only hydrogen, one hydrogen, which is a smaller inside. So there will be very less repulsion as compared to ketone. That's why aldehyde is more reactive than ketone. Aldehyde is more reactive than ketone. Are you getting my point? I will write a whole sentence about this. Have you got it, Austin and Humam?
yes.
Yeah, this is the reason I wanted to hear. Okay, so I'm going to write aldehydes are generally more reactive than ketones. Nucleophilic addition reactions due to a steric and electronic reason, or you can say due to a steric and electronic repulsion. Or you can write the presence of two relatively large substituent. That means alkyl group we are talking about. Alkyl in ketone hindered, that means repulsion will be there, hinders the approach of nucleophile to carbonyl carbon than in aldehydes. Than in aldehydes. Because one of the side you will have only hydrogen. So I think it's clear to both of you. Let me know when you are done with this. Are you done with this? Okay. Austin, so write the topic with me. Some important examples of nucleophilic addition and nucleophilic addition elimination. Nucleophilic addition elimination. Ingredients. So very important topic this is. There will be a lot of types of reaction and their name. So let's discuss one by one. First one is addition of hydrogen cyanide. First of all, let me know that this HCN is an electrophile or nucleophile. Can you tell me? Electrophile, nucleophile, you know that, right? Humam and Austin, both of you. What is nucleophile, Humam? Austin, tell me.
It gains electron.
It means electron. Humam, can you repeat it again? Whatever in your mind, just tell me. Did you say it gains electron? Mom, am I audible?
Yes, sir.
Did you say it gains electron?
No, I mean it donates electron.
It donates electron. Very good. So basically, nucleophile means nucleo that comes from nucleus, and phile that means lover or affection. So basically, nucleophile is the one which has affection of nucleus. Nucleus here stands for positive charge. And wherever generally on any substance or a molecule, there will be positive charge. That substance or molecule will have deficiency of electron. So that means this nucleophile will satisfy that substance which has deficiency of electron. So these two terms in organic chemistry is very, very important. Electrophile, electron lover. That means it is having deficiency of electron. That means electrophile. And nucleophile, that means nucleus lover. That means it donates electron. It will have more electron. It is having more electrons, so it will donate. So as you know that this is HCN and nitrogen has a lone pair, so it is acting as nucleophile. But you know, HCN is not that much good nucleophile. Any compound which is having negative charge and lone pair, let's say if you have OH negative and if you have H2O, something like this. So this will be more nucleophile affinity than this. All I want to say is that the one which is having negative charge will be more donating tendency as compared to the one which is having lone pair or neutral. Are you getting my point? H2O here is neutral, right? Neutral means no charge. So basically, if you are going to do this addition of hydrogen cyanide to a carbonyl compound, that means aldehyde or ketone, this is the nucleophile which is going to attack, but this nucleophile is not that much good nucleophile. So what we are going to do, we are going to react this HCN with base to make a very strong nucleophile. Now what will happen, this HCN is an acid, so it will be converted into H plus and OH minus, and this will be going with this. So H2O in the solution, H2O will be there and it becomes Cn minus. I did a mistake. When it is going to dissociate HCN, so it becomes H plus and Cn minus. Now this is a stronger nucleophile than HCN. Now what we are going to do, we are going to react this carbonyl compound. I'm just going to show this. Either you are going to replace one of the bond of carbon with hydrogen, it becomes what? Aldehyde. Are you getting my point, Humam? Please tell me.
Yes, sir.
Now here is your nucleophile. How did the mechanism goes? As I told you, what will happen? This will take its electron. So there will be delta negative, there will be delta positive. Here is your electrophilic center. So this will be attacking at this position. Now what you will get? You will get something like this. O negative is there. Cn comes here and two bonds are like this. If RR is there, that means it is ketone. Basically, wait a minute. If you have R or R is here, that means ketone, and one of the R is replaced by H, that means your aldehyde. So this is your intermediate, tetrahedral intermediate. After this, what I did, I reacted this with acid, that means H plus. So what it becomes? Cn. What is here? OH. Here it becomes OH, and here it is Cn, and the rest part is like this. And this is called cyanohydrine. So in board exams, they will directly ask you write a short notes on following terms like cyanohydrines, ketal, hemiacetal, semicarbaldehyde, something like that. They will ask you. Okay, so you have to write a whole sentence about this, and then you are going to show the mechanism or the reaction. Then only you will get full marks. Are you getting my point? Okay, please do write this. Then I'm going to write a whole point about this. We are not going to react with HCN directly to this carbonyl because HCN is a not a good nucleophile. We need a stronger nucleophile to react with carbonyl compound. That's why we dip this HCN in alkaline solution. So it becomes Cn minus, which is a very strong nucleophile. Let me know when you are done with this.
Answer.
Very good. So I'm going to write a point about this. That is very simple. Aldehydes and ketones react with hydrogen cyanide to form or to produce cyanohydrins. Basically, this reaction is very slow when you are going to use pure HCl. So this reaction is very slow with pure HCl. They can ask you this question as well. Therefore, it is catalyzed by a base and generate cyanide ion, generated cyanide ion, that means Cn negative, which is or being a strong nucleophile or a stronger nucleophile, as I told you this nucleophile, which readily adds up, which readily adds to carbonyl compound, carbonyl compounds, that means aldehyde and ketones. to produce corresponding cyanohydrate. To produce corresponding cyanohydrate. Please do write it. Let me know when you're done with this. Now let me know when you're done with this.
Done, sir.
Very good. So the next example is here. Very simple example. No, sorry. The next example is addition of sodium hydrogen sulfide. Sodium hydrogen sulfide. So first I'm going to write some points, then you are going to write it. Write it with me, then I will explain. Sodium hydrogen sulfide, that means I'm going to write directly NaHSO3 at the place of sodium hydrogen sulfide. Adds to aldehydes and ketones to form addition compound or addition for. Okay, the most important point I'm going to write about the position of equilibrium because it is a reversible reaction. So the position of equilibrium lies largely to right hand side for most aldehyde. Generally, for the aldehyde, the position of equilibrium will lies on the right hand side, and to the left for most ketones. Most ketones due to steric reasons. Very simple it is to understand, as I already explained that ketone has ketone has what do we say ketone has bulky group, so the reactivity decreases and aldehyde can be easily attacked because one of the side only hydrogen is there, so that's why due to this steric regions the equilibrium just wait a minute. The equilibrium lies largely to right hand side for what ketones, for most aldehydes, and to the left hand side for most ketones only because of steric reasons. Are you getting my point? Also, this is very important. They can ask you a question like uh, why aldehyde and ketones react with cyanide ion instead of HCN? Because in pure form, HCN is not that much good nucleophile as compared to cyanide ion. That's why we catalyzed with base to convert HCN into CN negative or CN minus. Okay. So please do write this point, then I'm going to show you the reaction. Let me know when you are done with this. Let me know when you are done with this. Both of you done with this. Oh, okay. Your after class assessment is uploaded or activated. Please do attempt that. Okay. Okay. Humam Susi. So this is your carbonyl compound, aldehyde or ketone. Now you are going to react this with NaHSO3. So see what will happen. Very simple it is. You know that this will be like this. So there will be negative charge, there will be positive charge. Now what will happen? There will be positive charge, there will be negative charge. So C with C O, and you know that this is positive, so it will go with negative, and this is negative, so it will go with positive. So ONA will come here, and this SO3 I'm going to write OSO2H, and it will be like this. And then in the next step, we are going to do proton transfer. Proton transfer, that means hydrogen will replace this Na, and you will get OSO2Na, and here it becomes OH, and the rest part will be as it is. And this has a name which is bisulfite addition compound, and it is crystalline in nature. So here we can write, this is your OH, so we can write its name as bisulfite addition compound and crystalline. Amorphous and crystalline we had to study in solid state. Crystalline, that means basically long range order solid. The particles present in this type of solid is orderly arranged for long range. So I think it's clear to both of you. Now let me know when you are done with this. Are you done with this?
Done, sir.
Austin. Okay. So this part I'm not going to do. I'm going to give you homework because we already did this in previous chapter. And Now I need it by Friday. I gave you another homework before this class. None of you did that. Why it is so? Now it's your exam. Exam is over. Mom, you are also free from your exam still, but you are not doing your additional work that I'm giving you. That is very important.
Yes, sir.
So when will you do it? The one which I gave you. I'm again going to remind you. Today is Thursday. I need it by tomorrow night. I'm going to remind it to you again. I wrote all the name. You took the screenshot, I think. So here it is preparation of aldehyde and ketones. In which one of them I already explained this, the hydration. Now you need to again take the screenshot. You are going to do it. Are you getting my point?
Yes, sir.
And again, I'm going to give you another Grignard addition of Grignard to this aldehyde and ketones that we studied in chemical reaction of aldehyde and alcohol, in which I'm going to remind you that we studied about when methanol or when you are going to react aldehyde with Grignard followed by hydrolysis, except methanol, you will get secondary alcohol. And if you are going to react methanol with the Grignard reagent followed by hydrolysis, then you will get 1 degree alcohol. And when you are going to react ketone, any member of ketone with Grignard reagent followed by hydrolysis, then you will get tertiary alcohol. This is what I taught you, and I want you to do that already in your notebook and send it to me by Friday, this and the previous one. Okay, both of you, is that clear?
Yes, sir.
Okay.
With examples and explanation like that, I have to write them.
Yes,
Right?
you just need to, the way I'm teaching you, like addition of Grignard reagents. So you have to do it for aldehyde. That means you are going to do it for methanol and other aldehyde. Okay, like you can take one is for RCHO. This is other aldehyde. R is alkyl group. That means methyl ethyl. It can be anything. And one is for HCHO. And you are going to react this both with RMGX. And then followed by, in the next step, you are going to do it for followed by hydrolysis, H plus and OH minus. And again, you are going to, the third reaction will be for ketone reacting with this and again with this. Then you will get it. Okay. And write it clearly, right? You should write your writing should be clear. Okay, so what I was going to do, addition of alcohols. So first I'm going to write the reaction. I'm going to explain it, then we'll write something about this as well. Okay, let's see if you have aldehyde. If you have aldehyde, so first you are going to react this with R dash OH, that means alcohol in the presence of HCl gas, dry HC. So what will happen? So I'm going to show you the reaction as well, how the reaction took place. Okay, now see how the reaction takes place. So you know that this is your RC and H is there, and then double bond O is there. Now what will happen? There is R dash OH. R dash OH means what? You know that this will have negative charge, this will have positive charge. Yes or no? Tell me. Now I can do this as well. This has positive, this has negative. So this bond will be broken. This positive will go with this and this negative will go with this. So what you will get, basically you will get CH, I'm going to write it like this, and then R is there, right? Two bond is here, and O negative, it is going O R dash, and then this will be like this. Yes or no? Tell me. Can I write this? Tell me, is there any doubt? and this is called hemiacetal. This is called hemiacetal. They can directly ask you what is hemiacetal. So this is how you are going to explain. After this, if you are going to again react to this, after this, if you are going to again react with R dash OH in the presence of acid, what will happen? Very simple it is. If you are going to do this, see, this is positive, this is negative, and this is positive. Sorry, this is positive, this is negative. So you know that this will go with this and this will come with this. So what you will get basically, you will get RCH, and here it becomes OR dash, and here it becomes OR dash along with H2O. Now you can see that this is your somehow ether. Ether, you can see RCOR, sorry, ROR, something like this. Ether. So if both the this carbon, if it is having Zem dihalide on the same carbon, this OR, so this is called acetal. And if on one carbon only one is there, hemiacetal. Like it is sphere and hemisphere. That means half of a sphere is hemisphere. So this is your acetal, which has two, and this is hemiacetal half. That means half of two is one. Are you getting my point? Very simple reaction it is. Please do write it and let me know. Then I'm going to write a point about this. Then we will react for, this is for aldehyde. We will go for ketone as well. Let me know when you are done with this.
Done, sir.
Very good. Now I'm going to write the way we did the reaction, like one equivalent of alcohol is going to react with aldehyde or monohydric. You can say monohydric, that means only one OH group is there. In the presence of dry hydrogen chloride, then you will get hemiacetal. Again, you are going to react with one equivalent of alcohol or further alcohol you are going to use, then you will get gem dihalide. So this point I'm going to write it here. So write it with me, please. So here how we are going to write aldehydes react with one equivalent of monohydric alcohol in the presence of dry halogen chloride. Dry halogen chloride to form or to produce or to yield, you can write. Generally in chemistry, we write yield alkoxy alcohol. Alkoxy alcohol intermediate. This is your intermediate known as hemiacid, known as hemiacid. Now, which on further reaction with, which on further reaction with one more molecule of alcohol. Alcohol to give gem dialkoxy alcohol. Gem dialkoxy, not alcohol now. Gem dialkoxy compound known as acetal. Is to write it. After that, we will do for ketone. Let me know when you are done with this. Are you done with this?
Yes, sir.
Now see for the ketone, what it will be. So very simple it is. This is your ketone, you know that. And we are going to react this ketone with ethylene glycol. So this is your ethylene glycol. I'm going to show you ethylene glycol. And this reaction is already also carried out in dilute HCl and HCl gas. Now what you need to do, very simple, you just need to remove water. H2 from here like this. To understand, I'm going to only tell you like this. And R is there. And this will be directly connected with this oxygen, which has CH2, and this oxygen, which has CH2 like this. And this is called ethylene glycol ketone. And you know the byproduct will be H2O. Right. So, we can write a point about this. Ketone react with ethylene glycol under similar condition. That means under similar condition, the way we reacted in that, or we can write under similar condition. You're not going to write it under similar condition when you are when you have been asked, say, along this to form cyclic product known as ethylene glycol ketone. Basically, the reaction will not be like this H2O removing from this and this. I just explained it to for you to remember it. It will be like protonation will take place, H plus minus negative positive. It will go like that. Now let me know when you are done with this.